Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this word problem using the concepts of derivatives. So as per the word problem, Sandy is making a closed rectangular jewelry box with a square base from two different woods. So the wood for the top and bottom costs $20 per meter square and the wood for the sides costs $30 per meter square. Find the dimensions that will minimize the cost of the wood for a volume of 4000 centimeter cube. Now the tricky thing here is that we are given the cost in terms of meters and the volume is given in terms of centimeter. So the first step should be to convert this volume in centimeter cube to meter cube, because we need the same units to analyze this problem. Now we know that 1 meter is equal to 100 centimeter. So in order to convert 4000 centimeter cube to meter cube, we should divide it by 100 three times because of the cube on the centimeter. So we do 1 meter over 100 centimeter times another 1 meter over 100 centimeter times 1 meter over 100 centimeter. So there's a very important concept we need to understand and memorize. If the units are not the same, then we'll get a wrong answer. So if we evaluate this expression, we get 0.004 meter cube. So this is the volume of this jewelry box in meter cube. Now let's start analyzing the problem by drawing a diagram. So this jewelry box is a square prism. So let's draw one. So we can draw a square prism like this. So the base is a square So since the base is a square, so all dimensions of the base will be the same. So let's assume the base is x units long on all sides. And let's assume the height of the jewelry box is y. So this is a prism, and for a prism we know the volume is, so the formula is length times width times height, and it can also be written as area of base times height. So volume will be equal to, so the length will be x, width is x, and height is y. Now we figured out that the volume in meter cubes is 0.004, so we can sub that in as the value of V. So we get 0.004 equals x squared y. So here we are assuming that x and y are in meters. So this is the equation for the volume of this box. Now we are given the cost of the top and the bottom and the sides of this box. So in order to write the cost for the whole box, we'll have to first find the cost for the top, the bottom, and the sides. So we have to find the dimensions that will minimize the cost of the wood for the whole box, not just one of the sides. So let's start with the base. So we know that the area of the base will be length times width, because it's a square, so it will just be x times x to x squared. Now the cost of the wood for the bottom or the base is given in terms of per unit area. So $20 per meter square. So in order to get the total cost for the base, we'll multiply this area x squared by 20. The total cost for the base will be 20x squared. Now the area of the top will be the same as the area of the base square. So the cost for the top will also be 20x squared, because the wood for the top and the bottom cost the same. Now the sides are made up of 4 surfaces, and each of those surfaces is a rectangle of dimensions x and y. So the area of sides will be, so the sum of area of 4 rectangles of dimensions x and y, so it will be 4xy. Each rectangle has area x times y, and since there are 4 side faces and they all have the same area xy, so that's why the total area of the sides will be 4xy. So the cost for the sides will be then the area of the sides, so 4xy times the cost for the sides, so that is 30. So this can be simplified to 120xy. So this is the total cost for the sides of this box. So now we can use these 3 costs to find the function for the cost for the whole box. So we can use the variable c. So c equals, so we start with the cost of the base, so 20x squared plus 20x squared plus 120xy. Now we can combine the like terms, so 20 plus 20 is 40, so we get 40x squared plus 120xy. Now this cost equation has 2 variables x and y, so now we can do the substitution for y from the volume equation. Now we should do the substitution for y, not x, because x exists in this cost equation in 2 forms, x and x squared. So it will be easier to do the substitution for y. So we can isolate y in this volume equation by dividing both sides by x squared. So the x squared on the right side will cancel each other out, and we get 0.004 over x squared equals y. So we'll do this substitution for y. So we get c equals 40x squared plus 120x times 0.004 over x squared. Now we can simplify this expression. So one of the x's will cancel each other out, and we have to do 120 times 0.004, which is equal to 0.48. So we can add here. So we can rewrite the cost function as c equals 40x squared and then plus 0.48 over x. Now we have to find the derivative of this cost function, because we have to find the dimensions that will minimize the cost. That means we have to find the x values at which the graph of the cost function forms valleys, and at the valleys the tangent will be horizontal, so the slope of the tangent will be equal to 0. So we'll find the derivative of this cost function and then set it equal to 0. So before we find the derivative, we have to move this x from the denominator to the numerator because that will make it easy to find the derivative of this function. So we get plus 0.48 and then x exponent -1. Now we can use the power rule to find the derivative. So prime of c equals, so in the first term 40 is the coefficient, so it'll stay as it is, and as per the power rule the derivative of x squared is 2x, and then plus 0.48 is the coefficient, so it will stay as it is, and as per the power rule the derivative of x exponent -1 is -1. We move the exponent to the front and then we subtract 1 from it. So we get prime of c equals, so 80x and then minus 0.48 and then x exponent -2. So 0.48 times -1 is equal to -0.48. Now we can set the derivative equal to 0. So we get 80x and we can move the x squared to the denominator to make the exponent positive. Now we have to solve this equation. So we have to isolate x. So we should move 0.48 over x squared to the left side of this equation. And if we do that, this fraction will become positive. So we get 0.48 over x squared equals 80x. Now we can cross multiply the denominator x squared, so we get 0.48 equals 80x cubed. Now we have to solve for x. So we have 0.48 equals 80x cubed, and now we have to divide both sides by 80. So the 80s on the right side will cancel each other out and we get 0.48 over 80 equals x cubed. Now we can change x cubed to x by applying cube root to both sides. So on x, the cube root and the cube will cancel each other out. And now we can just do a calculation here. So we get x equals, so now we have to do the cube root of 0.48 over 80, and that is equal to 0.182, and the unit is meters. So this is the x value at which the tangent is horizontal to this cost function that we found in terms of just x. Now we should find the domain for this cost function. So x represents the length of the base. So we know x has to be greater than 0. Now x won't have an upper limit because as per the volume equation, as y keeps on decreasing, x will keep on increasing. But y will never become 0 because if y becomes 0, then the expression will become, then the box will have no volume because y represents the height. So there's a very important concept we have to keep in mind. So we cannot test for the volume or for the cost at x equals 0 because if we sub in x as 0 in this cost function, the denominator becomes 0. So that will make the cost undefined. So that means there is only one solution here, that is that x equals 0.182 meters at which the cost will be minimum. Now since we have to find the dimensions, we also have to find the value of y, the height of this box, and for that we'll use the volume equation, and from the volume we isolated y as 0.004 over x squared. So we can sub in x as 0.18. And now we can evaluate this expression. So 0.004 divided by 0.182 square. So I got 0.121 and the unit is meters. Now in this problem we are given the dimension, the volume of the box as 4000 centimeter cube. So we should convert these meter values for x and y into centimeters. So for that, we should multiply the x and the y values by 100 because 1 meter equals 100 centimeter. So we get x equals 18.2 centimeters and y equals 12.1 centimeters. So that means the dimensions of the box that will minimize the cost for 4000 centimeter cube volume will be, so 18.2 centimeters by 18.2 centimeters. So that's the dimensions of the base times or by 12.1 centimeter. So these are the dimensions that will minimize the cost of this jewelry box. So these are the steps you have to keep in mind to solve a problem like this one. So it's very important to start with a diagram so that you can identify what the variables can be used in this problem, and then we write the equation for the volume, and then we find out the cost for the sides, the top and the bottom to make the cost equation for the whole box. So I hope you'll find this video useful. Please share it, like it and subscribe to Homework Help. Thank you very much and have a nice day. Bye.